is the set from KMPH 22-23 question number 3A. So the question are nitrosyl fluoride NOF is used as a solvent and as fluorinating and nitrating agent in organic synthesis. It has also been proposed as an oxidizer in rocket propellant. Two possible Lewis structure of NOF are given below. So there are two possible structure that give to us. So the first one, if you can see the first one and the second one. So let's move to the first question, Roman 1. So for the first question, it asks us to show the formal charge on each atom of structure 1 and structure 2. So for answering this kind of question, we need to state the formula of formal charge first. So formal charge of an atom in Lewis structure is equals to the total number of valence electron in the free atom minus the total number of lone pairs electron plus 1/2 total number of bonding electrons. Next, we move to the question. So for the structure 1 for nitrogen atom, there are 5 valence electron minus with the 2 lone pair. If you can see, there's 2 lone pair and plus half of the 6 bonding electron. For oxygen, 6 valence electrons minus with the 4 lone pairs plus half of 4 bonding pairs is equal to 0. So also for fluorine, 7 valence electron minus with the 6 plus half of 2 is equals to 0. So for structure 2, also calculate for repeated the same thing as we do on the structure 1. So we will get that 0, -1 and +1. Tips on to answering this question. If you can see, for oxygen, 6 minus 6 plus half of 2 will equals to -1, and 7 minus 4 plus half of the 4 is equals to +1. So on this question, we need to ensure we need to put the positive signs, because for the formal charge, the signs is very important. So we need to put, if it's positive, we need to put the positive sign. If it is negative, we need to put the negative sign. This is the most careless mistake that doing by students. For the second question, it asks us to determine the most plausible structure and explain. We need to state the structure first. So we state the structure 1 is more plausible structure because the formal charge of all atom is 0 as we calculate above. Okay, so for question B, illustrate the hybridization process in ozone O3 and determine its molecular shape. Draw and level the overlapping of the orbital. So for first we need to draw the Lewis structure of ozone. So this is the Lewis structure of ozone, and since there are 3 oxygen, so here I state it as OA, OB and OC. So we can differentiate which one O when we want to do the hybridization. We state the class. Class for this is AB3, and electron pair consists of 3, which is 2 bonding pairs and 1 lone pairs. Electron pair arrangement is trigonoplanar. The molecular shape will be band or V shape. So we need to draw the molecular shape here. It will look like this. So there are 1 sigma bond and the second sigma bond, and the other one is for pi bond. So the type of hybridization, as it has 3 electron pair, so it will be sp2. Move to the hybridization. So there are 2 atom will be undergo hybridization, OB. So OB as the central atom. Okay, so for the first O plus, it will be have 5 valence electrons since it's positive. So explain it in the ground state. O plus has 3 unpaired in 2p orbital, thus it can form 1 sigma bond. The paired electron in 2s orbital will not be promoted to 2p orbital, as we can form the sigma bond here, and this is one for the lone pair. In the 2s one is the 4 lone pair. So as it does not need to be promoted, so we just copying for the excited state. So O plus excited state, just write the same as the upwards. So for the hybrid state, so sp2, so 2s and 2p orbital hybridize to form 3 equivalent sp2 hybrid orbital. The second one that will be undergo hybridization is OC. So OC will be oxygen atom. So O at ground state, there will be 6 valence electron. So at ground state, O has 2 paired electron and 2 unpaired electron. Thus it can form 1 sigma bond. So the paired electron in 2s will not be promoted to the 2p orbital. So as it will not be promoted, so the excited state we just copy from the above. OC has 2 lone pair, so this is for the lone pair and this one is for the sigma bond. And the 2p is for pi bond, which will be overlapping. So 2s and 2p orbital hybridize to form 3 equivalent sp2 hybrid orbitals. So move to the terminal. OA will be O minus. So O minus will have 7 valence electrons. So just this is 2s and 2p orbital. So let's move to the drawing. So for this drawing, so the first thing we need to do is sp2 here, sp2, this one, and it will be overlapping with 2p, and it will be overlapping with sp2 for the OC. This is OB, OA and OC. So this is the first sigma bond. Second sigma bond between OA and OB. The next one is OB and OC, and after that we need to draw the 2p orbitals. So the first 2p orbitals for OB here and OC here. So these 2p orbital will be overlapping to form pi bond. So overlapping of sp2 of OB plus with 2p orbital of OA minus and sp2 orbital of OC will form sigma bond. Okay, so for question C, NCl3 is a polar molecule whereas BCl3 is a non-polar molecule. So which molecule has higher boiling point? Explain. So the answer are as NCl3 is a polar molecule and BCl3 is a non-polar molecule. Thus NCl3 has higher boiling point compared to BCl3. The presence of dipole-dipole interaction in NCl3 generally leads to the stronger intermolecular attraction compared to the London dispersion forces in BCl3. This results in a higher boiling point for NCl3 as more energy is required to overcome this interaction. So we need to state the interaction between NCl3 and BCl3. Then we compare which one is higher or lower. If the question didn't state whether it is polar molecule or non-polar molecule, so we need to state. So for the last question, D, by using electron C model, explain the bonding formed in aluminium and how could the model explain the electrical conductivity of aluminium. So the answer will be each aluminium atom release electron and form Al3 plus ion. So the positive aluminium ion Al3 plus is surrounded by the sea of delocalized valence electron, and the electron can move freely and said to be conducting electricity. Thus aluminium is an electric conductor. So as the question asks us to using the C model electron C model, so this is the electron C model. So here are 8 of aluminium ion. So each ion consists of 3 valence electrons. So the 3 will times with the 8 will be 24 electron. So the 24 electron we need to draw randomly in this box because it is C of the localized valence electron, so it will be randomly put. Okay, so that's all.